The Poisson distribution is very similar to the binomial distribution, but in this case, it's not a fixed number of trials. It's events that are occurring during a given time or space. The average rate at which the events occur is the same at all times, and that's usually represented by a lambda. The number of events that occur must be independent. If it happens once, it can't affect the other ones. And this is going to be found in the TI calculator under the distribution menu. And we'll talk about when we use PDF. That's when you're finding a specific X value. And if you're finding less than or equal to a value, we're going to use the CDF, Poisson CDF. Now we have to be careful here. So this example, the number of hits on a website during a given time interval has a Poisson distribution with an average of 3 hits per minute. That's a lambda 3. But we're going to let our random variable be the number of hits in a 2-minute period. So this isn't just happening over 1 minute. This is happening over 2 minutes. This is going to change how we put it in the calculator, and so the TI can be a little misleading. Actually, so can other apps. So we have to be kind of careful on putting it in the calculator. So if we're trying to find the probability that there are 5 hits during the time, that's finding a specific value. That's the probability of getting a 5. That's going to be under the PDF menu. Now, when I go into that, that's under second vars, and it's pretty far down. So binomial, here's the Poisson. It's right after the binomial. Now, when you first look at this, you would think they just want your 3, that's your lambda. But since this is happening over a 2-minute period, it's 3 times 2. So the 3 was over 1 minute. Over a 2-minute period, that would change to 3 times 2, or 6. Now, the X value we're doing is 5 hits during that time. And so I get 0.16, so that's the probability. Now, the probability that there are less than 3 hits, that's 0, 1, or 2. So we would actually have to think about it as being less than or equal to, not 3, because we're not including 3, but less than or equal to 2. Now this puts us in the CDF menu. And you actually, if you go from the bottom, like backwards, find it faster. CDF, now again, it's not just 3, because it's over a 2-minute period. And we want to know the probability of being less than 2. And I get 0.06. Find the probability that there are more than 2 hits during the period. Well, that would be the opposite of this. And remember, all the probabilities would add to 1. So I would just take 1 minus 0.06. That's the probability of being greater than 2 would be the opposite of less than or equal to 2. And so that would be 0.94. All right, let's do another one. The number of traffic incidents at a certain intersection follow the distribution with 2 per year. So the lambda is 2. But we're not talking about just 1 year. We're going to be talking about the number of accidents that occur in a 4-year period, so T is 4. Find the probability that there are 7 accidents. That's the probability of 7. This would be a PDF. So, second vars, PDF, 2 times 4 years, and we're looking for the probability of getting a 7. That's 0.1395. That's basically 0.14. Less than 4, but it doesn't include 4. So that would be less than or equal to 3. That's a CDF in a 4-year period. So CDF, 2 times 4, less than or equal to 3. 0.04. It's actually 0.042, but that's okay. Find the probability that there are more than 2. Oh, more than 2. Okay, so I would have to find the probability of being less than or equal to 2 first. So I'm going to change that to a 2. And that's 0.014. 0.014. The probability of being more than 2 would be 1 minus 0.014. 1 minus 0.014, and that's 0.986.